Hey guys, it's Bill from Linden, Tennessee. So if you will recall, several videos ago, maybe a year or so ago, I made a video about my little lawn tractor that I converted to electric. I kind of did that when we first moved out here to Tennessee about 3 years ago or so. And since then, I've kind of refined its design. And one of the things that I did was, instead of having a belly mower on the tractor, I took a belly mower from an old Cub Cadet and turned it into a pull behind mower that I run an extension from the tractor to this, and it powers the motor through a switch over by my seat. And originally the motor was mounted about right here, and it went through the same belt, and it had like a tensioner, so I would reach under the seat, turn the power on to the motor, and then engage the tensioner so that the blades would turn. I never wanted to have the motor always attached to the blades, because doing that puts a high load on the motor when you initially start it from a stop, and it causes arcing in the contactor. And our contactor is sort of designed for that. Unlike a relay, a contactor is a little bit different. But it's sort of designed for that, and it can take it, but it can't take it a lot. So I always wanted to have some sort of a way to start the motor without putting too much load on the contactor, and having it start free and then apply the tension to the belt to put the power to the blades was a way of doing that. That was one thing that I always wanted to upgrade. The other thing was, with the motor mounted up here, it was putting a lot of tongue weight onto the device here. As it is, with the wheels way back there, sort of all of the weight of this whole thing is resting on that tongue, and then you go and add another 40 pounds for a motor, and it ended up being, almost 100 pounds, or right at 100 pounds of tongue weight on that, which is fine for the tractor, but it's not really fine for the for the little 1 inch or 1 1/4 inch square tube that I use for the hitch. So I wanted to move that. So what I did was, it occurred to me I've got this 2-inch receiver that I mounted back here when I built this thing, that I never really knew what I was going to do with it. I just kind of had it laying around. I thought, hey, why don't you put that motor on the receiver, and then that way you can use a screw to tighten the belt, and maybe you could take the receiver out, take the motor out much easier, and transfer it to other devices. So that's what I did. And the first device that I tried to see if that would work is this here chipper. Originally, this had a 15 horsepower gasoline engine on it, and it was noisy, of course, and it stunk, and this thing had oil all over it from oil changes, because they put the oil change plug in a really awkward location. But so it was just kind of a mess, and it was noisy, and it smelled bad, and I don't like it. So this is my first implement with the interchangeable motor. So that's pretty cool. So this is just 1/8 inch steel. This piece, and this is all just 1/8 inch steel. And so here's the tensioner I was talking about, and then these bolts just sort of screw into the receiver itself to hold the mount solid, so that the motor doesn't flop around and constant tension is kept on the blades, or on the belt. Lining this up was kind of a fun challenge. Turns out that if I put a jack stand under it at full extension, the motor balances right on it, and it was good enough that I could hold everything a little bit in place while I made my brackets, and like tack welded it to get it started. And then once it's tack welded, you can get rid of the jack stand and make the rest of the brackets. But yeah, and as far as alignment goes, with a belt, you don't really have to be that dead on. You got to be kind of close, but there's a lot of play in it. But I got it as close as I could, and so that's pretty cool. But I was still faced with that problem of starting the motor under a load. So what I did was, I went on Amazon and I got myself a little motor controller. So for $30, this is a 40 amp motor controller. I think it's from like 9 volts up to 60 volts or something. So it can handle a good amount of amperage, wattage, for starting a motor. Now this isn't any good for actually running the device, because that thing could, it could pull well over 100 amps while it's running and it's chomping up wood or while I'm cutting the grass. So what you do is I've still got a contactor on this thing. So what you do is you put power on this, turn on the little knob, run it up, get it up to about, 90 or even high speed. And then you flip the switch and you hit the contactor. I've got a little momentary switch. So you flip this up and this sort of arms the contactor. And then you push the button and that goes to the holding circuit and the contactor stays on. And if you're interested, here's a wiring diagram of how all that works. There's my 45 volt packed battery. And then a little 12 volt battery runs the relay. Yeah, I'm not going to go too much in this, but basically this is my momentary on switch. That's the arm switch that I just showed you, and then that's the ignition switch. So the ignition switch and the arm switch both control this relay. So you turn the ignition switch on, and the little momentary switch won't do anything. But you turn the ignition switch on, and then you turn the arm switch on, and then now this holding circuit is engaged. And whenever you do that, it closes the contactor for the 48 volt that goes to the motor. In this case, motor. It's actually the plug on the back of the tractor, but anyway, ultimately it is a motor. And then this is your sort of soft start, what I'm calling it, speed controller, and you got a power that goes in, and you got the motor output that goes there. The power, the two positives for the power and the motor are tied together, because these speed controllers, they only control the negative side. So what you do, like I said, you turn the knob, you get it up to 90, 100%, whatever, and then you flip the switch, turn the contactor on, and it just jumps straight across the output of the speed controller so that you've got full battery voltage and amperage to the motor. And at that point, the speed controller is not even in the loop anymore. So that's pretty cool. So I'll show you how that works. So you come up here, you turn the power on. I say that. Oh. I got a little relay on, I got a little switch there. So you come up here, turn the power on. I say that. Why is it not working? There we go. So you come up there, you turn the power on. So here's what's going on. I've made a few errors over time, and the 48 volt system is actually grounded to the frame, which is a little odd. You normally don't do that, but in this case you kind of have to, the way the controller works. It needs a ground reference, and it ties the ground reference to the 12 volt, which is kind of annoying, but it's a low voltage system, so it's not that big of a deal. However, if you happen to short the ground to the positive terminal on the motor or whatever, because remember I said any kind of controlling device, whether it's a relay or contact or a fuse, is usually fused on the negative side. So the positive side is almost always hot, if you will. So if you ground the positive to the frame, then it's a direct short, and this is the little wire that sort of provides that short. They call it short, provides that ground reference. And so I did that once. I grounded it accidentally, and it just killed the whole system because this wire actually burnt out right in the middle. So what I did was I put a little 4 amp fuse circuit breaker in there. So that way now if anything shorts, it'll pop that fuse, and it's the end of that. Saves the wire, saves everything. So that was the problem. I had that open. That's why it wouldn't start the first time. So I closed that. And the reason it wouldn't start the second time is because I had this on all the way, and the inverter for the traction motor won't come on because it sensed that there was some kind of a load on the 48 volt side. So now I've got that turned off. So that's off. The circuit breaker is on, and now you can hear the contactor. Right, so now we're armed. So now we can come up here, turn this on. Like I was saying, so now we'll run this up to about 80 or 90 volts, arm the system, push the button, and now you can see this doesn't have any effect on the motor control because we've got the contactor providing all the juice. Look at this. there it is. And the way to turn this thing off is flip this off. That opens my contactor, and then you allow it to sort of slow down on its own. There's a lot of flywheel weight on that. Yeah, so you let it slow down, like slow down a lot till it's almost stopped. And then when it's stopped, you can go ahead and turn that off. Let me tell you something, what I just learned. What you don't want to do is have that thing running and then turn this off, because this short circuits the motor control. And if you do that with it running, the motor is now being turned by the flywheel effect of the choppers in the thing. And it's a generator. And if you close that, that generator goes full circuit and will burn up the inside of this thing. That's what this one's for. Because that's what I did. This is actually take 2 of this video. So that's 2 things. That's one thing you don't ever want to do. The other thing you don't want to ever do is come over here, flip the arm switch, and then hit this contactor, because that short circuits the system and it'll blow this up too. So that's 2 things you don't do. Don't turn this all the way off while it's going, and don't turn this on while this is off. So basically, out in the field, what you do is you just leave it kind of at like 10. That way you can turn this. Now, if I were to turn this on right now, it would just spin the motor up fully through the contactor, and which is what I was trying to avoid with this thing. But it's just a few things to think about. And the other thing is this switch controls forward and reverse, so this will actually reverse the motor. And if I did that, it won't work. So don't do that either. That's 2 things to do. I'm going to hot glue this now so I can't accidentally hit it. So there we go. So now I'm going to go out and see if this thing works. Be right back. Okay, let's see if this works. Well, I'd say that was pretty successful. Seemed to have no trouble getting through that stuff. One of these logs I shoved in there, I mean, it clearly cut it. And maybe it was fine. I don't know, but this is like the first time I'm using this thing, so I don't really know what I'm listening for and stuff. So that's pretty cool. One thing I'm going to need for sure is I'm going to need to put some kind of I put a piece of screen, like window screen in here to keep stuff from getting out of there. But I need something a little bit more than that. So heck yeah, man. This thing ain't even warm. Not even breathing hard. Now this isn't, well, I don't know. This is pretty green wood. This is all from cedar trees and stuff that I chopped down a while back. But I've got a lot more to do. So what I have is also is a little trailer with a hitch on the back of it so I can pull that trailer behind me with a shovel, and I can, you know, get all this stuff off the ground and put it into the trailer. But cool, man. That worked fabulous. All right, so here's how this kind of works. So I went back in that sort of larger piece of branch that I kind of shook my hand at. I wasn't sure if it was going to work or not. I had Cindy come out and look at my amp gauge while I was doing that because I wanted to see what this does, and I figured, you know, if I'm going to see what it really does, I need to maybe break it. So had her come out, look at the amp gauge, and I just shoved that big old piece in there. It's probably, I don't know, maybe 2-inch or something like that. It's not exactly green, but it's not old either. But and she was watching the amp gauge, and it only pulled like 90 amps. That works out to maybe 5 horsepower. And this motor I'm using can do, you know, up to 15 horsepower, but 5 continuous. So it wasn't even breathing hard just to get through that one little branch. And this chopper can do up to 4-inch branches. So I don't have any doubt that this motor will have enough power to pull through that. And that's kind of interesting. This is why electric vehicles win driving. And I'm not talking politics, and I'm not talking the climate, and I'm not talking green deals or any of that crap. I'm just talking vehicles and power and why they're going to win. And it ain't got nothing to do with those things. You know, ultimately, this chipper had a 15 horsepower engine on it. And it, you know, why? Because gasoline engines are just not very efficient. They have a very, very narrow peak horsepower band. You need a whole lot more horsepower in gasoline than you do in electric. It's just how it is. So, you know, when you see an electric car that's got 200 horsepower, you're thinking, oh, that's not that much. But then you see it accelerate, and you're like, I don't understand how that works. Well, that's how it works. Electric horsepower is not the same as gasoline horsepower. It is not the same. I mean, the torque curves of an electric motor, everyone knows, is just completely different than a gasoline engine. The torque curves on these things, this one in particular being a brushed direct current motor, goes from full torque at no RPMs, or well, I guess technically at 1 RPM, 5 RPMs, and it just maintains that full torque all the way up to 3,000 RPM. You know, and it's a flat curve. You look at the torque curve of a gasoline engine, and you have no torque. You've got enough to keep the thing idling at idle. If you put any load onto that idle without giving it more gas, it's just going to die. If you get the RPMs up to 3,000 or something, it's got plenty of torque. It's got the full rated amount, but you have to get it up there, and that peak is, well, it's peaky. So anyway, electric rant over. But yeah, this thing works great. I'm really pleased with it. It looks cool too. I like how it kind of all tucks in there. Yeah, so I'm gonna go around the yard and pick up some more of these sticks and make some more mulch. Thanks for watching.